I mean, if you, it's really wise to be able to look at a fitting and see what it is so that you can look at it and say, this is, I need a, you know, 1/4 inch pipe, whatever. And because a lot of times on the cars, your sensors will be 3/8 pipe, some of them will be 1/2 inch pipe. Like on your older Chevrolets, the engine coolant sensor went inside of the block because I remember it was 1/2 inch pipe, which is that bigger side that it shows you. But anyway, this right here is a little thing we talk about fun with an old Jeep that I worked on. That we actually did this work here, but I had worked at a Jeep dealer, and so I was kind of familiar with these. Incidentally, this service manual, in case you ever need it, you can find it online if you know where to look and download the whole thing, the entire shop manual for the Jeep CJ7 Scrambler. This is a 84 to 86. You know, they were pretty much the same. And naturally, my phone's going to want to ring right now. Hello? Wait a minute. I know what that was. Never mind. That was nothing more than an alarm. Never mind. All right. Whenever you see a Jeep, and there's people out there, these Jeeps, a lot of these Jeeps, you know, those 4-door fancy Jeep Wranglers you see driving around, they cost about $50,000. They're really expensive, but they got a lot of resale value. I mean, a lot of times, you know, you can just about always sell a Jeep. You know, that junky old one that we had that we put the engine and the transmission in, the black one, you remember that? There was a girl that came over here that she was interested in that Jeep, said, I would like to buy that Jeep. And I said, it's a piece of junk. You know, I said, it needs an engine and a transmission. She said, I don't care. She said, I'll buy it just like it is, because she was wanting a Jeep. She didn't care if it needed, what it needed, or what she'd have to spend to get it going. She wanted a Jeep, and she thought she'd buy that one. Well, anyway, the simple fact is, some of the old timers say the Jeep actually won World War II. You know, because they just thought that was the grandest thing in the world now. Anyway, I had a Jeep, one like that I traded my cousin Billy out of back in the real early 80s. And he had it sitting under his shelter, and he wasn't doing nothing with it. He wasn't ever going to do nothing with it, but I traded him an engine for his dad's pickup, because I had a 318 engine that I had built. And that engine, his dad's pickup had like 300,000 miles on it, he didn't want an engine for it. Anyway, traded for it. That's what the engine looked like, a little flathead engine. And it was tremendously under square. It had long rods on it, little bitty pistons, that kind of thing. And believe it or not, I could go to Dothan Auto Parts over there, and I could buy all the parts that I needed, rings, bearings, gaskets, seals, to build that engine. And that little 4-cylinder. And so anyway, I put that thing together, and I tore it down there and pushed the pistons out of it. And the rear main seal was one of those rope seals. I don't know if you've ever seen those old rope crank seals, but anyway, I always hated them and everything. But it had one of those in it. When you put those in there and you first torque it down, they're real tight, you know. So what I did was, I finally got it bolted back together. I hooked up my dad's 66 C20, he had a 3/4 ton Chevrolet pickup truck, and I dragged it across an open field out there with the trailer ball hooked on that truck. And when it started up, that thing was in 4-wheel drive, and it pushed me all over the place before I could get it shut down. And after that, I could start it with the key. And I drove that thing, and the top speed on it wasn't but about 45 miles an hour, it seemed like, and it was real low geared. It was really a workhorse of a vehicle. And it felt like it weighed 10,000 pounds when you were driving it around. Like it felt like it'd be really hard to turn it over. Had low center of gravity and all that. I just worked on the steering and all that. I mean, I did a whole lot of work. I put an oil bath air cleaner off of a Carmen Ghia on it, and the carburetor on that little thing was in such bad shape there was no way you could get it to run right because it had too much clogged up junk and stuff wrong. So I got a little bug spray carburetor off of the Carmen Ghia, and I built an adapter for it and put it on there. And I had that thing fixed up really nice. It ran smooth as silk off that Volkswagen carburetor. But anyway, that was the deal on that. That was a little thing I just said already. But Chris came to me about this 84 CJ. This is the actual vehicle that you recognize our shop here. He had washed the engine, and it hadn't run right since. Have you ever washed an engine and have it not run right since? Zane's learning about it on his phone. All right. He couldn't rev the engine above 2,500 RPM, whether it was loaded or not, without it sputtering and popping and cutting up. It would pop and cut up and sputter. And he had done everything he could to dry everything out. Now, this guy didn't fall off the turnip truck. He's a pretty intelligent guy, and he had done a lot of his own mechanic work, but he was sort of at his wit's end to listen to know what to do with it. They brought over here, and we said, well, we'll see if we can figure out what's going on with him. He's basically thinking maybe, and this is what happens. You steam clean it, and everything seems like it's fine for a little bit, and I mean a very little bit. And have you done that before? Or wash the engine off and then it starts cutting up on you, and you gotta do, what do you do? What do you do to dry it out?
Why not just open the hood up and let it set for a couple of days?
Smartest thing you can do is take the distributor cap off and spray it with WD-40,
Done that too.
and that'll wire it right up. Why do they call WD-40 WD-40?
Water displacement.
There you go, it displaces water.
Why is it 40?
Yeah, because it was the 40th formula they tried. They tried 39 other formulas, it didn't work, and that one did.
Yeah,
All right, so I started it up when he brought it in, and I brought the RPM to 2,500. There's a little aftermarket tack on it. And when the engine started misfiring, the tack started bouncing towards 0 and then back up to 2,500. Now what does that mean? The tack bouncing down and back up to 3,500. Now on the older ignition systems, and this is a sort of a vague rule of thumb and a generality, downward bouncing tachometer on the older ones usually indicates a primary ignition fault. An upward bouncing tack points to secondary ignition faults like high secondary resistance concerns. So primary is low voltage, which will be your module, your points, this kind of thing. High voltage is going to be your coil wire, the one that shocks you, you know, and all this stuff. And so if it's bouncing up, you typically got a secondary problem. If it's bouncing down, you got a primary problem. That's not true 100% of the time, but it's a general, you know, rule of thumb. All right. It's almost sounded like a rev limiter strategy on a fuel-injected vehicle, only not quite so rhythmic. You know, rev limiters are whoom, 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 whoom. You've heard that. This one here was more of a sputtering and cutting up, and this vehicle did not have rev limiter strategy on it. So it's easy to drift off track. We kept reminding ourselves the problem had manifested itself after the engine compartment was doused with high-pressure spray. He washed it really good, made it really clean, then started having this problem. So you're thinking there's some kind of water somewhere. Now, I'm going to pause just for a second. One time this guy that I was working with at the Ford dealership over there had the engine out of a Ford Ranger. Pulled the hood off, took the engine out, the hood was in the back of the truck, and he had to wait for parts for some reason. I don't know what the hell it was, but he needed to move other stuff into his service bay, so he shoved this thing outside. And it sat out there for 2 or 3 weeks. Finally, he got all the stuff so he could put the motor back together, so he built the motor back up, shoved the thing back in here. It was one of them, you know, late 90s things that had fuel injection on and all. So he gets it back in there, and it's running terrible. It's puffing black smoke, and he can't get it to do anything right and all that kind of thing. And he just called me over to look at it. And I looked at it with him for a minute or two before I said, wait a minute, this is the truck you pushed outside that was out there for a while, because I kind of recognized the color. Oh, yeah, that's the one. They said I had the hood off of it, because, you know, we got all the people. We ran 100 cars a day through the shop over there. And so there's a lot of work moving really fast. And so I told him, I said, if this sat out there with those connectors open, I bet you got a bunch of connectors with water in them. And so we started unplugging the connectors he had plugged back in when he put the engine back in, and when we started blowing them, you can't always see it. He started blowing them with air, a whole bunch of water comes splattering out of those connectors. Water's conductive if it's got any minerals in it at all. And so blew all of the water out of the connectors and plugged them back in, and he was running just fine. You know, I mean, but see, this is a lot of times it's just something simple like that. You don't have to look for something mysterious every time. All right, so I said, well, you know, we sort of looked in this direction here. So the way Jeeps were in 1984, they started tightening emission standards, and American Motors put together a feedback fuel system for the 4.2. Now, carburetors and oxygen sensors always sort of a peculiar deal going on. And so what they would do is it would meter the air with this little solenoid right here. If it would read a rich here, and the MCU would read this, then it would change the metering of the air to make it do all of that. I need to see what the sound hell's going on here. All right. Let me see. All right. So here we go. We got they pieced together this thing right here, and those oxygen sensors with a little one-wire sensor like we talked about the other day, and this thing right here was okay. So basically, you can see it wasn't that complicated, really, right? Not really that big a deal, fairly easy, and that's why carburetors were so wonderful, is because they just weren't complicated. You know, I mean, you can look at that real quick and just figure out right quick what to do on that. And so you know, some people would say, well, I'm gonna pull all this stuff off and throw it away and just have a carburetor. You could do that, but it would run like crap. You know what I mean? I mean, you have to do a heck of a lot of modifications. That's pretty interesting here. See, here's the breather, PCV air in, PCV air out. See that? It's pulling the air out of the crankcase and it's going in here, making a circle, right? All these vacuum lines. I don't know at the time. We would have a line mechanic that wasn't be all that great at these vacuum lines, and he could turn wrenches and he could pull heads and put them back on. He could do all this stuff. And then when they got through, they would bring it over to me with all of this junk just hooked up every kind of which way or not hooked up at all. And I would have to follow the schematic and figure all of that stuff out. So if it took me 3 hours to figure out what he should have put back together, they subtracted 3 hours from his flag and gave it to me. So he was costing himself money by not understanding it. Wasn't everybody, but there were a few line mechanics we had over there that were really good at nuts and bolts, but they were terrified of stuff like this. So they always gave it to me to straighten out. Understanding how that works helps. Here's the wiring on it. The wiring on it wasn't quite as bad as the vacuum line, but you had to understand what was going on. You know, obviously there's the distributor, there's the coil, there's the ignition module up there. You might notice, I'll show you another schematic here in a minute. All of this stuff right here was pertinent stuff. Sometimes you would have one that would run bad because of one little small thing, you know, that you would never expect would make it run bad. So you had to know how to make all this work right. So it's outfitted with a Carter carburetor, with a special stepper motor, and there's your connector for it. And it tells you the stepper motor connector, you got brown, red, pink, yellow, and basically you'll have one of those that'll be hot and it walks around, and the rest of them, as I remember. But anyway, doesn't meter the fuel to control the mix, it meters the air. Now the old computer command control GM cars metered the fuel. They had a little idle mixture solenoid that clicked up and down 10 times a second. And if you ever open the hood on one of those old cars like that, and you could hear that little solenoid click, and they go click, 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 and coming out of the carburetor. So if it goes down, that leans the mixture out. If it comes up, because you're basically stopping up the jet part of the way with that metering rod. If it comes up, you're running full rich. And you had to use a dwell meter to tell where that was. Right? So anyway, one of the most interesting wrinkles of this system was the way the AMC system handled the computer-controlled ignition. All right. Now, one of the things that I found out early on, I said, I'm going to plant some bugs and make these guys really good. I think it's 91 Chevrolet S10 that I had out here that ran really good. And I just pulled a distributor cap off and sprayed water up in there. And I put it back on there and I fired it up. It ran like brand new. One time I pulled all the spark plugs out of the Oldsmobile and beat the gap shut on them. Put them back in, it fired up. It ran bad, but it fired up, you know. And that was just amazing to me that it even started at all. It should have been a no start with a gap been shut. Now, if you've been and shut and dipped them in oil, it'll do it. But anyway, so this was the water's got to condense in droplet form on the underside of the cap in order for the moisture-related crossfire to occur. People used to tell me you could get a pencil and color inside a distributor cap and it would make them cut up and misfire. Well, somebody else may have had that experience, but I didn't. I took a distributor cap off line, but I marked all inside of it with a pencil. It still ran like a new truck, you know. All right, this line engine run fine right after washing. It stalls out on the way back from the car wash. That water tries to evaporate and made its way into the distributor, and it gets up into there. Now, sometimes on the Fords, they had the gray distributor caps on them. The ozone that's made every time a spark pops would react with that gray material, and it would make something on the inside of them caps that looked and acted like moisture, but it was kind of a clear syrupy stuff. We used to have issues with that. The way they combated that is they put a little vent on the cap so that ozone could get out of it. Every time you make a spark, you can make an ozone. Now, if this Jeep's problem had been intermittent, we would have connected the oscilloscope first, but because the engine never failed to dump at about half the horsepower and torque, the students opted to take some exploratory measures. You know, I told them, hey, when I shut the scope off, hey, we want to look at the plugs and stuff. So anyway, they decided to pull it all out of there. And so this guy put on the Jeep, removed the distributor cap right away to see if there's any water in it. There wasn't any water in there. And this is incidentally a Motorcraft distributor, by the way, just like you find on a 6-cylinder Ford. The cap was dry before connecting the oscilloscope. He pulled the plugs out for a quick look. They were in fair shape, but spark plugs are cheap, so he screwed in a new set. Incidentally, some of the distributor caps that GM and Ford used, they made them bigger. You know why they made them bigger? Got any idea? They made them bigger around with those little firing lugs farther apart, so it'd be harder for them to jump to the wrong post. The reason they did that. Now the sputtering and popping stayed unchanged because we hadn't touched it yet. We looked for moisture, we put plugs in there because they didn't cost much. Time to move on to the next level. When the RPM was increased, the scope gave us our first relevant piece of data. Above idle, it knew there were only 6 sparks popping, right there. And at 2,500 RPM, we literally lost every other firing line on the way. Now the Jeep uses this ancient 153624 spark pattern common to straight 6 engines. Above the 2,500 line, it turned to 1-3-2. It was only firing on 3 cylinders, right? And so, what do you think might be wrong with this now? What would cause that? What do you think? You gotta burn your way through that and think it out. Nobody knows. What would you do? What would you do next? Now we got to track down the problem here. Got to figure out what's going on. It had a module on it, like that one right there. That Duraspark. Okay. Everybody's waiting for me to spoon feed them the answer. That's what we're thinking through. All right. All right. Come on, buddy. Clamping the inductive pickup of a timing light around the plug wire leading to each of the 6 cylinders, we kept moving from front to rear looking at the timing light, and we found out cylinders 4, 5, and 6 were going dark above 2,500 RPM. All right, see, basically what we were trying to do there was zero in on exactly what the problem was and which cylinders are we losing so that we maybe could get a better idea of what was happening. So I either hadn't seen that before or I forgot about it. I can't remember ever seeing that, or if I did see it, I didn't get this deep into figuring out what was wrong. So what on earth could cause it to lose half its spark events at a certain speed? Well, this Jeep ignition system includes an MCU, microprocessor control unit, I showed you earlier, as a part of the ignition equation, and we didn't have any spare parts for an ABA swap. If you had another MCU, you could just plug that in. Of course, it's aggravating to get to because it's in there behind the dash and all that stuff. Looked just like a Ford one. Now, this was based on the old Duraspark 2 setup, but they inserted the MCU. There's your ignition module, there's your MCU, there's your distributor. That MCU is between the distributor and the ignition module. Now, if you remember, you know, the ignition module actually feeds the coil there, and you got hot and start run, and then you got just hot and start, and then you got your timing output right here. Now look how the Ford one changed. Pay attention now, because this slide's going to change if I did it right. Nope, I'm going to do it this. Get back up. See if I can get it to swap there. Okay. Wow, that's amazing. I did that, but it won't act. It won't act right now. Probably because I'm using a later version of PowerPoint than I was for an earlier version. This right here, I'm just going to draw this for you. On the old Ford, these two went straight over here. There, right over there. On this one here, they put this in between there. So basically, I did a lot of work drawing that too. But anyway, let's move on. The engine RPM should be raised to 1,600 when adjusting the ignition time. And if you don't put the RPM at 1,600 when you're setting the timing on one of these and unplug those 2 little vacuum switches at the back of the valve cover, you ain't gonna set it right. You're gonna have all kinds of problems. The sticker specs under the hood call for 9 degrees plus or minus 2. What most people would not catch is that it has to be at 1,600 when you set it. Now, to strengthen the ignition system's foundational general principle, we adjusted the ignition timing. I've seen misadjusted ignition timing cause strange problems. You know, not exactly like this, but this one guy worked on one of those 3.8 Fords, and the guy that I had trained, and he said it was cutting up and acting crazy. And I said, if you looked at the timing, well, on that one, it was real aggravating because you had to have a mirror. You had to shoot into the mirror to see the timing and then make the adjustment. Well, you had to have ratchet wrists and 5 hands to do it. And he kept saying, yeah, check the timing. But when he finally checked the timing was too far advanced, and that was his whole problem. He burned about 2.5 hours on it, but he should have checked the timing to start with. Well, the timing wasn't set right. We had to retard it several degrees and bring it to spec, but that didn't change a dadgum thing. We felt like, hey, we found something. Nope. All right. When I verified the foundation, it's basically supposed to fix the foundation before you go up to the house. If you've got a weak spark, all bets are off. If the timing's not set right, all bets are off. If you got spark plugs that are burnt, slam them up, or you got wires with a lot of resistance, all bets are off. You fix all of that stuff, make sure at least that it's in good shape before you go on up. Or I go to work on the primary side to eliminate different components and portions of the circuit. But I worked on a 98 Explorer a few years back that was sputtering and popping kind of like that. It felt like rev limiters, going wong, wong, wong. But it was doing it at about 4,000 RPM, which is a heck of a lot lower than rev limiter on a Ford. Some of your GMs have a rev limiter that low. I guess they're afraid they're going to come apart, whatever. But anyway, I determined the problem was in the primary ignition signals to the coil pack. The PCM's here, the coil pack's here. There's 3 little wires. This one turned out to be really weird. See these little wires right here? Those little wires, you can actually, if you build another little wire harness, you got to hook them up to the right pins now. You can't just throw them in there any kind of way. I built some wires that actually had the right connectors on them that I could snap them in there, and I replaced all 3 of these wires because I knew it wasn't the coil pack, and I knew it wasn't the engine controller, so I replaced just those 3 wires going there, and that stupid thing still would hit that rev limiter symptom about 4,000 RPM. And so basically I said, well, I call the field service engineer, and he says, replace the entire 12A58 with 81 engine wire harness. You know, I mean, that's a lot of times that's what the field service engineer will tell you. Just hey, throw a wire harness at it. Well, that's easy for him to say. That thing's a booger bear. It runs everywhere. But I put one on there and it fixed it. And I asked him about it, and he hauled around. He really didn't know what. He just got lucky with that guess, but he could authorize that expensive wire harness, and the labor it took to put it on there, but we got the guy's truck fixed anyway. All right, now, as far as the Jeep was concerned, we decided to remove the ignition module and use jumper wires to connect it directly to the distributor in the ignition coil. That way the MCU would be out of the loop. So let's just hook the DuraSpark module directly to the distributor like it is on a Ford, so it can fire the coil independently of the Jeep electronics. That's how it looked whenever we got it laid up there and we had our jumper wires running everywhere. You know, I love jumper wires. We use jumper wires around here all the time. All right. So he pulled the ignition module, rewired it to take a signal directly from the distributor like an old Ford system. And we did that. And it still acted the same way. Didn't do a dead gum thing different. Still lost every other cylinder when it was firing. Pattern was still there. So the ignition module itself was the most likely cause of this problem. So we got an ignition module. Had it sent over there, we connected it to the jumper wire, and we hooked it up like an old system too, and it gave us a normal pattern and normal performance. All of the firing lines were still there, and we mounted it. Incidentally, it's down at the bottom on the back side of the driver's side fender below the stupid water bottle thing. It's, you know, it's not that hard to get to, but it's crazy they put it way down there. He had a brother that he used to race with across plowed fields with them Jeeps, and I says, if you'd reach under there and jerk his module loose and plug this crappy module in, and that would just mess him up something terrible, at least temporarily. It wouldn't hurt nothing, you know. All right, but troubleshooting the system without being able to understand the big picture is frustrating. If you don't understand the big picture, what everybody typically wants to do, I mean, if you're working in the field or if you're working here, and when I was at the Ford dealer, I found out that, you know, go in there and just shotgunning it and throwing stuff at it and maybe getting lucky and finding something, that doesn't happen a lot. You know, a lot of the times, especially if you're working at the dealer, the shops around have already worked on it, and the dealer is the last stop, and you've got to fix it because everybody else hasn't been able to figure it out. And they've already replaced all the easy stuff, and so they left you with having to figure out what's actually wrong with it. A known good part's not always available, and we can get unpopular with the parts guy if we're always borrowing parts to try. It gets nastier when the parts got to be ordered if it's expensive, if the problem's an intermittent, and the vehicle comes back with the same concern, somebody's got to wind up eating the cost of the part. And that's just nasty stuff. Well, I found I learned a lot more if I go in there and I surgically try to find out what's wrong, and then I finally figure it out by doing the elimination. I'm always like to, if there's any way possible without buying any parts, I like to find the problem. Now, when I do find something, I'll fix that first, and then I'll double check it to make sure, kind of like we did on the Expedition. You know, if I see a leak here, but I mean, I knew good and doggone well that wasn't going to be the only leak. That thing got a hold. But anyway, getting an insight and understanding adds to our mental library and makes us better troubleshooters. So who wants to be a good troubleshooter? That ain't, you know how you get to be a good troubleshooter? You do a heck of a lot of troubleshooting. That's the only way you can do that. You got to be able to take what you've learned and apply it to what you're doing. And whenever somebody is, you know, it'd be really nice if we could just go out there. Some of the people I know that have the idea that they think they want to be a mechanic feel like they'll be like the people at the parts house. They'll just pull a code, change a part, and it'll be done. That ain't the way that works.
You know,
Now, sometimes you get lucky and you pull a code and change a part, but then you think you got the mouth. There was a shop over there in Dothan when we were doing a lot of Power Stroke diesel work. And those guys managed to hack their way through and fix several of those Power Stroke diesels to the point to where they felt like they were Power Stroke diesel experts. I got no problem with that. I mean, you know, we worked on those things. You know, they always came in there, we'd work on them. Well, this one shop over there was calling for the calf rope because they were trying to figure out, I don't even remember what the problem was, but they had spent $3,000 or $4,000 on parts and labor on that thing, and they hadn't even touched the problem. Because they got one that got them over their head, is what it about basically amounted to. And that happens, man, you know what I mean? You can think, just because you got good success on 3 or 4 or 5 of them, you know, the 6th one's liable to bite you. You know, sooner or later you're gonna have something that somebody's gotta figure out. And anyway, it can be nasty. So, okay, got a question, comments there? Anybody got a story? You ought to have a story. You've been doing a lot of stuff here lately on your own stuff.
not troubleshooting.
Not with troubleshooting? All right, you did some troubleshooting this morning on the Ranger though.
Yeah.
And Zane did. All right, we're going to lunch. Lock up.